At constant pressure, which of these systems do work on the surroundings? Check all that apply.
I'm going to write these out quick. So it's A plus 2B equals C, right?
Yep. AS plus 2BG equals CG.
So next one, 2A.
2AG plus BS equals 3CG.
Okay.
And then, do you want the rest of them?
Yeah.
AG plus BG equals CG. Last one's 2AG plus 2BG equals 5CG.
Okay. So remember when we had the work equals pressure and the change in volume? This is kind of what they want you to be thinking about. This is the kind of conceptual part to it. This is the mathematical, this is the conceptual.
So and it's on at a constant pressure.
Yeah.
Is that just ideal so you understand the concept of it?
Yeah. That's why it's kind of a good idea to just slowly go through each of them, because as you can see, they're kind of stepping you through some of the basic concepts.
Building on it.
Yeah, like even though you haven't read over this chapter, you haven't gone over it in class, taken notes or anything, you're still able to go through it as long as you've kind of read a little bit in the book and have a little help on it.
Right.
So, what we're looking at is we want to change in, we're looking at change in volume or change in pressure? Which of the systems does
Pressure
work?
is constant.
Okay, so
At
pressure.
constant pressure, and so it's changing
All right,
volume, I guess.
right. So our change in volume is what we're going to be concerned with.
Right. And so then it says which of these systems do work on the surroundings. So
Right.
volume is the only thing that's variable.
Right.
Okay.
So you know how you'd approach this? Or do you have an idea?
So, no, not really.
Okay, so what we're going to be looking at,
I don't see where C comes from.
basically this is just generic reactions. That's why they haven't put anything in here. Is all
So you
they're
have
looking
some sort of gas plus some sort of gas.
and
equals
it's reacting.
Some sort of gas.
Yeah.
Okay.
So what's happening is here is that we're having some reaction, and all that comes out of this reaction is this C gas.
Uh-huh.
So what we're going to be looking at is our volume changing? So right now we have 3 moles on this side of the equation and 1 mole on this. Would you say that our volume has changed?
Yeah.
It has. So that means our volume, did it go up or down?
Went down.
Right.
So
So
your volume went down.
is it going to do work on the surroundings? If we think about what delta V has to be. If it went down, delta V would be positive or negative.
Negative.
Right. So pressure, which is constant, times a negative number, we're going to have negative work.
Right.
Negative work means that our system didn't do work. It's actually receiving work.
From an outside system.
Yeah. There's work pushing in.
Oh, that makes sense. So that didn't do any work on the surroundings. That took work from the surroundings.
Yeah.
Oh, interesting. So the next one is 2 plus B, so you'd be looking at 2 plus 1,
Mhm.
in essence, so it'd be 3, and then it was 3 on the other side, so it washed through, so it didn't do anything.
But B's is solid. Solids don't affect volume. At least not the same way a gas would.
Right, so it's, you only have 2 gas. The solid would just be there.
Being there. Yeah.
It could be the jar or whatever. You never know.
Yeah.
Right, okay. And then 3, so that means that it did add some work.
I would love to see that reaction because that'd be so cool. You just put like a gas in a jar and it just dissolves and floats away. That'd be awesome.
And then you get some
Yeah, that'd be
get
awesome.
work out of there.
Yeah, but basically you're going from a small volume to a larger volume, which means that this system expanded,
Right,
which means that it put work out.
right. It would be a positive for work out, so that one would technically apply.
Yep. So that would apply.
Surroundings.
Right.
Interesting. So this one, gas and a gas, so you get 1 and 1, so 2, and then it ends up with 1, so that one would be negative 1
Yep.
volume, so it had work coming into it.
Yeah.
So that would qualify.
Yeah.
So 2A, 2B, so you'd get 4, and there was 5, so that means that it added 1 to the system, so that means that one would qualify.
Yeah.
1 going out.
Yep. It'd expand the system.
Interesting.
Because if you think about it, if the pressure isn't going to remain constant, that basically means that your containers are going to be rigid. This kind of assumes like you have a piston or something that can move.
Meaning it's got a set volume area, it's not
Yeah.
gonna change.
Yeah, so if you think about the
Pressure's
volume
gonna
change.
Or like a tire maybe.
Yeah, like with the last one. So let's just say we've got the 2A, 2B in here. This is where it starts at. If we wanted to add in another mole of gas but keep the same pressure, this piston has to move up to change the volume so that the work remains the same.
Gotcha.
Not that the work remains the same, but so that your pressure remains constant. If you don't change this, basically you're cramming more
Your
stuff.
pressure would be
Yeah.
increased. So
Yeah,
your
because you're
volume
cramming
has
more
to-
stuff into less
Right.
space.
That makes sense.
Alright.